Alright, good morning. Welcome to the continuation from 2.5. So we need to solve each rational function and express the solution or solutions in interval notation. To do this, we're going to need to find the zeros of the function and where it's undefined. So the zeros of the function are going to be when the numerator is 0, and that's going to be a 4, and where it's undefined is when the denominator is 0. So undefined. So it's going to be undefined at r minus 1, which is just going to be 1. Alright, so if we draw this and we say, okay, r minus 4, and I'm going to put my 0 in here at 4, and where it is undefined, call this 1. I'm just going to do this to show that. And then we're going to have our second equation is going to be r minus 1. So take a really big negative number, or should I say just take a really negative number, and like a negative 1,000,000, and put it in here. So you're going to get negative 1,000,000. This value really doesn't matter at that point. Over negative 1,000,000, subtract the number from it, you're still going to be in the negatives. So this is going to be in the numerator it's going to be negative, and in the denominator it's going to be negative. Between 1 and 4, pick a value like 2. So if I plug 2 in here, I'll just put 2 here. So 2 minus 4, I'm going to get a negative on the top. And then r minus 1, if I put 2 in here, I get 2 minus 1, and that's going to be a positive value. And then I have my 0 here at 4. And from 4 on, put a really big positive number in here, and it's going to stay positive. And then in the numerator, if I put that same positive number in there, it's going to stay positive. Okay, so it wants to know where this function is going to be greater than or equal to 0. So it's equal to here at 4, and it's greater than everywhere we have these double positives or double negatives, or same sign positive, different signs negative. So from negative infinity to 1, excluding 1, union from 4, including, because it can be 0, to positive infinity. So that's going to be my solution. I know that we didn't graph these in class, but I know I've been talking about graphs and stuff like that, so what I want to do is go ahead and graph this guy so we can see. And we're going to use this line graph to basically fill in the graph. So okay, so 4, I have a 0, and at 1 it is undefined. So this is my 1, and I draw a vertical asymptote. And then when let's see, we're going to have r over r, so that's 1. So we have a horizontal asymptote here. And this said that the value is going to be positive, right? Negative over negative, so the value is positive. And the only way it can be positive is to be above this asymptote. It's going to cross the y-axis at negative 4 over negative 1, so 4. So we'll say that's 4. It's going to cross this axis and it's going to approach this asymptote and just keep getting closer and closer to it. And then over here, it's going to come from this asymptote. It's got to go through 4. It can't cross that asymptote, or it's not going to. Shouldn't say it can't. So there are cases where it can. So it's going to approach this this horizontal asymptote and this vertical asymptote. And just looking at this inequality, we can see from that where is it greater than 0? Okay, well, it's from here. Notice this is all above all the way to this asymptote, right? Excluding this asymptote. And then from 4 to infinity, it's above. So the graphing still works if you know how to graph them. Okay, so our next problem is x squared minus 4 over x. When is that greater than 0? Alright, so what are my zeros? That's when the numerator is 0. So I'm going to factor this and I get x minus 2, x plus 2, or x plus 2 times x minus 2, however you want to look at it. So this is going to be a positive 2, this is going to be a negative 2, so my zeros are a negative 2 and 2. And the function is going to be undefined when the denominator is 0. So when x is 0, this thing will break. So now we'll draw this line. Alright, sorry, I got interrupted by my kids. Here we go. So what was I saying? Okay, so it's going to be undefined at 0. And at negative 2 it's going to be 0. And I'm just going to put the function here. So this is where it's 0. And at 2 it's going to be 0. And then I'm just going to kind of figure out what happens in between. And we have the value x. So we can just do x first. So take x, really big negative number, going to be negative. In between here and 0, these are still going to be negative numbers. And these are going to be positive numbers like positive 1. And these are going to be positives like positive infinity. And in the numerator, we're going to take that same really big negative number and square it. And remember I said that was like if I owed you $1 million and I gave you 4 of it, yeah, I didn't even put a dent in it. So in between here and here, notice that this is squaring, so we have negative 1 squared minus 4. So that's going to be 1 minus 4. So these values in between negative 2 and 0 are going to be negative. Over here, in between 0 and 2, plug a value like 1. So 1 squared minus 4 is going to give me a negative value. And then really big positive number, square it. That's still going to be a really big positive number. This part isn't going to matter. So these values are going to be positive. And what it's asking us is, when is x squared minus 4 divided by x greater than 0? So it's going to be everywhere we have the same signs. So I'm going to do this. Negative divided by negative is positive. Negative divided by positive is negative. Positive divided by negative is negative. Positive divided by positive is positive. So my solutions are here and here. So now I can say, okay, from negative 2, not including, to the value 0, not including, and then we're going to have a union from this negative 2, excluding, to positive infinity. And that's going to be my my solution set to the inequality. Okay, so the next inequality we have is x squared minus x minus 6 over x. So draw our number line. And the things we are going to identify are our zeros and undefined. So our zeros are when the numerator is 0, so I'm going to factor, or try to, hopefully this works out. Put x there, x there. So we have -6 and 1. Alright, so I'm just going to write this over here. Maybe you already know what it is. But I have two numbers when multiplied together give me -6, and when I add them they give me this -1. So what I know is that it's got to be one's got to be positive, one's got to be negative, and 3 times 2. So I have a 3 and a 2, or a 2 and a 3. So I know that the negative is there, so the negative has to be bigger. So it's going to be this guy here. -3 plus 2 is -1. And those check out. Like I said, that's just, I always do the little table. So we have x minus 3, x plus 2. So our zeros are going to be -2, 3, and it's going to be undefined when the denominator is 0, and that is going to be when x is 0. So we draw in where things are happening on this graph, our spots that are going to have issues. So we have -2, and then we have 3, and these are zeros. Let's put that there. Alright, so now x squared minus x minus 6. And on the bottom we have x. So let's just go ahead and fill in the x. So really, if this is negative, and then these are still negative, and then this is going to be positive, and these are all positive. Okay, so let's see. X squared minus x minus 6. What I'm going to do here is I'm only going to look at the x squared term, because that's going to be the boss no matter what. So if I took a really big negative number and I squared it, it's going to be a positive number. In between these two values, we have -1. So if I took -1 and I squared it, or you can look at it up here, and you go, okay, -1 minus 3 is going to give me a negative number, and -1 plus 2 is going to give me a positive number, so these values are negative. And then from 0 to 3, we have, let's choose 1. So if I plug 1 in here, I get 1 minus 3, that's going to be negative, and I get 1 plus 2, that's positive. And if I take infinity and put it in here, this becomes positive, and this one becomes positive. So these values are all positive. So now we go positive, there are different signs, negative, same signs, positive, same signs, positive, same signs, positive. And I'm going to verify that between 0 and 3. I'm going to do this one more time. So at 1, so we have 1 minus 3 is negative, 1 plus 2 is positive. Okay, I must have said something wrong there. Let me verify that one more time. 1 minus 3, that's going to be negative, and then 1 plus 2 is going to be positive. So this guy is negative. Alright, so now what we want to do is go ahead and do this interval notation. And the inequality wanted to know when it was greater than 0. So everywhere there's a plus, it's going to be greater than 0. So in between -2, and did it say equal to? No. From -2 through to 0, can't include 0, a union from 3 excluding to infinity. And we can look at the graph too. So this guy's going to be zeros at -2 and 3, undefined here, and it's not going to have a horizontal asymptote because it's x squared over x, or just x, and should go off into infinity, off to infinity. Okay, so we said that from we're going to have negative values from negative infinity to -2. I wrote that backwards. And then in between -2 and 0, we're going to have positive values. You can see that. So do something like that. I'll graph it on a calculator too, just so we can see it. Maybe my graph is ugly. And then on this side, in between 0 and 3, they're negative. And then from 3 to infinity, they're positive. And actually, this should mimic this one. So this line, I think, should be more something like that. Alright, let's pull up this calculator. Okay, so I went ahead and graphed this thing, and you can see how this goes through -2, off to, and this red line that runs straight up and down is the asymptote. It should be on 0. What I'm assuming is that they've offset it, so that is 0. The black line is 0, and I guess their way of graphing it, the vertical asymptote, instead of being on the line, is just next to it. And then we have this where it comes up and it goes through 3 and it goes off. But notice that there's symmetry. If I took this piece of paper along the line y equals x, and I just cut a line right here, if I drew a dotted line, and then I flip the piece of paper over, this will match this curve. Or will it? Might not. So I'm thinking does it have symmetry? Maybe like this. I mean, obviously they have some type of symmetry. But anyway. Okay, so for the last one, we have 1 over 3k minus 5 minus 1/3 is less than 0. So what I'm going to do here is I'm going to combine these fractions. So we're going to have 3 times k minus 5 minus 3k minus 5 all over 3 times k minus 5. It's less than 0. So I got 3k minus 15 minus 3k plus 15 all over 3k minus 15. Now, and I might convert this back because the only reason I distributed it was just because that's what I was doing. Okay, so 3k minus 3k, negative 15 is 15. So this just becomes 1. over 3 times k minus 5 is less than 0. Okay, so now we want to know where our zeros are. Well, there are none. Nothing in the numerator. It's always going to be 1. Which means my values are probably always going to be, you'll see. Undefined. Well, it's going to be undefined at positive 15 divided by 3. So all I did was take 3k minus 15 and I set it equal to 0. I got 3k equals 15. I got k equals 5. So when k is 5, this thing is undefined. So there we go. So what happens to the left? Well, plug 4 in here. 4 minus 5, that's going to be 1, or that's going to be negative. And we have the value 1. So everything for the top is positive, because it's the number 1 and it's a positive 1. There are no variables. And in the numerator to the right of 5, we have like really big negative, or a really big positive value like infinity. And I stuck it in here and multiplied it, or took away 5. It's still going to be really big. Multiplied by 3, it's going to be 3 times that size. So the values are going to be positive. So to the left of 5, we get positive divided by negative is negative. And on the right side, we get positive divided by positive is positive. And then it's got to be less than 0, so it's going to be everything over here. So we have from negative infinity up to 5, excluding 5. And those are going to be the only values. Let's see. Let's go ahead and graph it. Okay, so as we can see here at 5, we have that vertical asymptote, and all these values, I don't know if you can see it, but let's try to zoom in. Yeah, now we can see it a little better. You see how it's almost to 0? So these values are all negative up to 5, and then these values are all positive. And if you zoom in over here, they're going to do the same thing they did here. They're going to approach this line y equals 0. Alright, so the first thing we want to look at here is C. Determine whether the quantity x plus 4 is positive or negative when x is greater than negative 4. So here's the question. When x is greater than negative 4, I don't care about what happens over there. When x is greater than negative 4, is it going to be a positive or negative? Well, we've been doing this, so this should be really easy. So when x is greater than negative 4 and this x plus 4, we can see that we plug a really positive number in there and add a little more to it, and you're going to get a very positive number. So we're going to say it's positive for this one. And now it wants to know what happens when x is less than 4. So I'm going to draw the same line. This would be the value positive 4. And we want to know what happens here. So I don't care what's going on over here. And it's the same x plus 4. So take values. And I'm going to put a 0 here. So what I'm going to do here, let's see, x plus 4, set that equal to 0. X is equal to negative 4, we get a 0. So this is negative 4. And what I want to know is what happens when x is less than 4. So we're not going to infinity. Let's see. What happens on this side? If I plug a really big negative number in here, it's still going to be negative. In between negative 4 and 0, if I plugged, and this is my 0, if I plugged negative 1 in here, it's going to be a positive. And from 0 to 4, it's going to be positive as well. So we want to know whether it's positive or negative when x is less than 4. Well, when x is less than 4, it's going to be negative up to negative 4, and then it's going to be positive till 4. So it's going to be a mix. It's going to be positives and negatives in between there. When is it okay to multiply and divide both sides of an inequality by a negative number? Well, you can do it anytime you want. You just have to remember to flip the sign. E. Does adding or subtracting from both sides of an inequality mean that you have to flip the sign? No. It doesn't change the inequality to add or subtract from both sides. And if you have to flip the sign of an inequality, what does that mean? That means that you divide it or you multiply by a negative number. Alright, and this really was the end of 2.5, or 2.45. 2.5.